Welcome! It's Miss Skelton here, and this video is going to help you know how to graph all lines no matter what form their equation is written in. So I'm going to work through these notes. I'm going to start on the left and kind of go a column at a time. Feel free to pause and work ahead and then check and see if you're on the right track, or rewatch certain parts to make sure that it makes sense to you. So first thing we're going to do is we're going to graph given the slope, so remember that's our rate, and then a point on the graph. We're going to always have a starting point. So if we're given a point, we're going to plot that first, then we're going to count the rise over run, and we're going to make sure we connect it and extend it with a line. Graph a line given the point 2, -7. So remember, ordered pairs are written with their x value first, so I'm going to move along the x-axis to +2, and then down to -7. 1, 2, 3, 4, 5, 6, 7. Phew, just have enough space. And the slope is -3. So remember last class we talked about how our slope is a rate, rise over run. If the slope I'm given is not a fraction, I'm going to make it a fraction and put it over 1, and then use that to help me move. So if I see -3, that means I'm going to be moving down 3 over 1. Since the 1 is positive, we're going to move to the right. So I'm at the bottom of my graph. I want you to kind of picture moving down 3 over 1. Okay, well, if you run out of graph, we can actually do both steps completely backwards. So instead of down 3, right 1, we can move up 3 and left 1, and it's making the same exact line. So up 3 and left 1. So even though up 3 would be positive, because we're moving to the left, that's like we made the 1 negative. It still divides out to be -3 total. Once we have a couple of points, then go ahead and extend that line. So the important thing is that we have a starting point. Most of the time that starting point is going to be the y-intercept. Here I can see the y-intercept is 0, -1, but that's not the point I was given at the beginning. Okay, if we have a word problem, I'm not going to have us graph this one, but we have to identify the slope or the rate. We have to find a point. Usually the y-intercept is given and it's the initial point of the situation. Label the x and y axis with units and graph. So let's just talk through this one. The cost to rent a car is $50 plus 10 cents per mile. When I see 10 cents per mile, I know that's my rate. So y equals 0.10x, and there's a $50 fee, or maybe a starting amount. So even in a word problem, that y-intercept, because there's a one-time fee of 50, that would tell me where to start my graph. And then based on how we labeled the equation, that 0.10 would be our rise over run, our rate that we would move by on the graph. Okay, let's practice doing some that are going to fit on our graph and just try some without words. So if we have slope-intercept form, y equals mx plus b. Anytime you see the equation in that form, please get excited, because it means we can jump to the graph straight away. We're going to identify the slope m and the y-intercept. We're going to start on the y-axis with the y-intercept, use the rise over run for our slope, and then connect it. So m and b, I know this is in slope-intercept form with y by itself. M is -2/3, and b is 5. So remember, that's the point 0, 5. So we're going to begin at 5 and then move with the slope m. So B tells us where to begin, m, the slope, tells us how to move. So when you see a negative slope, like we have, that's telling us we're going to move down 2 for the negative 2, but to the right 3 for positive 3. So start at your y-intercept and move straight down 2, to the right 1, 2, 3. We just found our second point. Do that again. From this new point, move straight down 2, to the right 3, and then let's connect that. It never hurts to use a straight edge or ruler. And I can tell that the line starts at 5, it has the correct negative slope, and it makes a decreasing line. Okay, let's look at the next one. Y equals 2/3 x. Okay, so if I think of y equals mx plus b, it's easy to see m. With x, I see 2/3. Now there's nothing added at the end, so another way I could write this is with plus 0. The y-intercept is 0. So let's begin at 0, 0, at the origin. If there's nothing added or subtracted at the end. And then my slope, I'm moving up 2 and right 3 because they're both positive. So up 2, right 3, put a point. Do it again. Up 2, right 3, put a point. If your line suddenly looks crooked, it means that you miscounted somewhere. Okay, and here I can see that my x and y-intercept are actually both 0, 0. It's where it crosses the x and y axis. Okay, let's keep going. The next one says graph y equals -3. Okay, so if I'm thinking of slope-intercept form, I don't have an mx. So I'm going to rewrite this. There is no x, and then put my -3 or -3. That's going to help me know that the slope is 0, and I'm going to begin at -3. So let's go do that. So I just counted down to 0, -3. And then think about a slope of 0. That means it's going to be a flat line. It's not sloped up or down. So we need a horizontal line that goes through -3, showing us that it's not sloped up, it's not sloped down. Before we go back to the top, I actually want us to do the question next to it, graph x equals 5, because it's another special case of line. So here, it doesn't look like it's in any form we've talked about. It just says x equals 5. So if we only have one variable in the equation, it's going to make a special type of line. If it only had y, it only goes through the y at that number. If it only has x, we want to go to where x is 5, so start on the x-axis. It's the only time you ever get to start on the x-axis. 1, 2, 3, 4, 5, because usually we're starting at our y-intercept. And if I need my graph to make sure it only goes through x of 5, that's going to be a vertical line, and every single point on that line has the same x of 5. So anytime I have an x only, it's vertical, only through the x. Every time I have a y only, it's horizontal and goes only through the y. So these are two special cases, horizontal, vertical. Okay, you can tell really quick by looking at the other four we haven't done yet. None of these are going to be special cases, because all of these have y and x. X and y and x, x and y. So I know they're not going to just be horizontal or vertical. Okay, let's try this second column. Graph an equation in point-slope form. So point-slope form, we're going to talk more about it next week. I want you to write this out. X1 and Y1 are just a point, and we're going to see them as numbers in the equation. But we practiced this last unit. We want to solve for y. That's why we did those steps before. Because if I have it solved for y, then it's going to be in slope-intercept form. So let's review those steps. If I see a number in front of parentheses, I know that it needs to distribute. So 2 times x is 2x. 2 times 1 is positive 2. And now to make y by itself, I need to cancel the minus 3 by doing plus 3. Remember, on the right side, we only get to add to its like term. So I'm going to put plus 3 under the 2, since neither of them have x or a variable with them. And now y is by itself, and I get 2x, and 2 plus 3 is 5. So I had to do a couple of extra steps, but now it looks like what we just graphed before. So let's identify our slope and y-intercept. Plus 5, b is 5, so I'm starting at the point 0, 5. And mx, m here is 2. Let's make that a fraction. 2 over 1. So I'm going to have a rise of 2 and run to the right 1. So up 2, right 1, put a point. Okay, that tells me how my line looks here. Now remember to make a nice line backwards. Instead of moving up 2, right 1, I could move down 2 and left 1, and that's still going to help me make the same line. Down 2, left 1, down 2, left 1. So notice if I start on the left at one of these points, up 2, right 1, up 2, right 1. The pattern is applying throughout the entire line, keeping my constant rate. Okay, I would pause the video and try the next one myself. I'm going to keep going though. So I see a negative in front of the parentheses here. Let's switch colors really quick to make it nice and neat. So if I see a negative, I'm going to think of that as a negative 1, and then distribute into my equation. So y plus 4 equals, the x is going to become negative, and a negative times a negative is always a positive. Now that I've distributed, I'm ready to cancel the plus 4. Minus 4, minus 4. It only gets to combine with the 2. And I get negative 1x. 2 minus 4 is negative 2. So my slope, m, with x is negative 1. My y-intercept, b, is negative 2. So let's begin at B on the y-axis at -2. And then the slope, let's make it a fraction. -1 over 1. And I'm going to move down 1 from the negative and right 1 from positive 1. Down 1, right 1, down 1, right 1. Making a decreasing line. And there we go. So no matter what form it's in, we can always change it into slope-intercept form. Y equals mx plus b. Okay, so on our last two, that's an option. Now it's not the option listed on the paper, but I'm going to go ahead and show you one where I just solve for y, and then one where I use these steps. And again, it's going to do the exact same thing. It'll make the same line no matter which method you pick. So I'm going to go ahead and look at this equation, x minus y equals 6, and choose to solve for y, just like we've been doing since the last unit. So I'm going to subtract x, y still has a negative. I'm even going to put a 1 to remind me it has a -1 with it. X is now negative, but the 6 is still positive. Remember, I'm keeping them separate because they are not like terms. Now I'm going to divide everything in the equation by -1. And think of it as -1x over -1. So -1 divided by -1 is +1. And then 6 divided by -1, -6. So now let's graph this. My slope is 1. My y-intercept is -6. And I'm going to make that slope a fraction. So let's start at -6. And then because my slope is positive, I'm going to move up 1, right 1, up 1, right 1. I like to put at least 3 points to make sure I have a nice straight line. So one option when it's in standard form, which is where I have the x and y on the left side equaling some number, like these here, one option is just solve for y and graph. The second option makes us find our intercepts. So think back to last class period. We found our x-intercept by putting a 0 in y's place. So I'm going to use this other method to graph the second one. Again, you have a choice. So it says plug in 0 for y. I'm just going to write it so you know what I'm doing. So 4x minus 6 times 0 equals -12. 6 times 0, I know, is 0. So that leaves me 4x equals -12. And when I divide by 4, I just found x equals -3 as my x-intercept. So we found that the point -3, 0 is on this line. Right there. Okay, the other option is to take, or not the other option, the next step would be to find my y-intercept. So it says we can find the y-intercept by substituting a 0 for x. So let's plug in 0 for x this time. Same exact equation, except now it's 4 times 0 minus 6y equals negative 12. 4 times 0 is just 0. So negative 6y equals negative 12. And when I divide on both sides by negative 6, I get y equals 2. So it tells me that my y-intercept is 0, 2. Let's go plot that point. And as long as you have 2 points, you're ready to connect it and make a line. So in this alternate method, it only works on standard form, we can find 2 points really quickly and then connect them. The only thing we don't find, which is sometimes important to know, is the slope, but you could count it. So I could count from this x-intercept up 2 over 1, 2, 3. I now know that the slope is 2/3. Okay, so you do have a choice on this last method. You can either solve for y and then graph your equation, or you can find your intercepts first and connect them. And it may even depend on the problem. Some problems might need you to know the intercept, so I'd want to pick the intercept method. Some might ask you about the slope, so it's best just to solve and know the slope right away. Alright, if you have any questions, let your teacher know. Hopefully you're feeling more confident in your ability to graph and to analyze linear equations, to know their intercepts and their slope.